This video will take you through a brief overview of the average value of a function. So just from a theoretical standpoint, just trying to get people to understand, what exactly does this mean? I want you to think about the following example. Let's suppose that, you take a bunch of tests and quizzes, right? Now to get the average of those tests and quizzes, you're going to take all the tests and quizzes, sum them up, assuming they're all weighted the same, and divide by the number of tests or quizzes that you have. Well, it's really no different when you talk about the average value of a function. You need to take all the values of the function, add them up, and then divide by the width of the interval that you're concerned about. And so you can see right in your notes here that we have a couple notes. One of them is that this is not average rate of change. Rate of change implies that there's some type of derivative involved, whereas average value, especially based off of the description I just gave, is the average of a set of values, right, summed up, and then of course divide that by the appropriate number. So that keyword there is sum. So you can see in the notes, right, we have this 1 over b minus a, and then this integral, which we have come to understand really stands for the sum of an infinite amount of rectangles, so to speak, right, Riemann sums, if you will. So there's an alternate way of writing this, and that would be to take the integral itself, right, which is the summation of all your values that you're interested in over this interval, a to b, and divide that by the width of the interval. And really it says the same thing, so we'll put a little or there, but you're really saying the same thing. So I want to walk through example 9 with you, and then you can kind of try 10 and 11 just to make sure you kind of understand what's going on. So in example 9 it says find the average value of the function f of x equals, and I'm going to write this a little bit more user-friendly for what we're going to do, 9x to the negative third power, and we're going on the interval 1 to 3. So basically all they want you to do is 1 over 3 minus 1 times the summation or the integral, right, from 1 to 3 of this 9x to the negative third power function. So we're dealing with 1/2 times 9. I'm going to go ahead and bring that 9 out before I do anything. Integrating x to the negative third, so x to the negative second over negative 2, and then evaluating that from 1 to 3. So again, keeping in line with just taking the constants out, looking at this in a little bit more efficient manner, right? We're dealing with negative 9/4 times 1/9 minus 1. So your final average value here should equal, nice and neat, 2. So I know I went through that a little quick, but really there's nothing that new there. You've seen the fundamental theorem and how that works. You're just applying that now into an average. So for instance, if you asked me to find the average velocity, right, average velocity of a function, then I would need to take the integration of that and divide it by the width interval that you're interested in. So it's really no different at all. So let's have you try example 10 and 11. So good time now to pause the video. I'll set it up here. Example 10 and example 11. And when you're ready, come on back and we'll get you some answers. Okay, set up for example 10 would look this way, right? 1 over 4 minus 1, integral from 1 to 4 of the given function, 3x squared minus 2x. And when all is said and done with that one, you should get a nice even 16. 11 is a little bit more involved. Has this real life type of application, and we'll look more at accumulation and functions and things of this nature, particle motion, in class specifically and using this packet. But if you look at this graph carefully, they're giving you the velocity of this drone. So to find the average velocity, you got to add all the velocities and divide it by this width, this time interval. So what we're really doing here is we're actually taking the area, right, from, it looks like 0 to 30, right, during this 30-second race. Okay, we're getting total area, and then all we're doing is we're dividing by 30. And it doesn't come out quite as nice as some of the other problems, but you should get a 24.667, and then we talk about what's your units, right? So it's average velocity. So in this case, if you look carefully at the graph, it's feet per second. And that's all there is to it.